So we talked about the 3 different stages of a thunderstorm. That's like the ones with an updraft, they call it cumulus stage. Updraft, downdraft, they call it mature stage. And only downdraft, they call it a dissipating stage. So the updraft and downdraft are not shown here. This quite possibly is a supercell. Remember we talked about supercells. Supercells are characterized by a mesoscale rotation, okay, where your updraft and your downdraft basically wrap around each other. And I say a supercell because actually supercells are with those mesocyclones kind of in the core of your thunderstorm cell. They're great at giving you a wall cloud and then maybe a tornado, if that's what your goal is, okay? So these are some features. Remember, we have it basically hitting the tropopause and kind of flattening out, giving us an anvil. Instead of overshooting tops, they call it penetrating tops. Same thing, nice and crispy, shooting into the stratosphere. Okay. So kind of some logistics or semantics. I think this is interesting where tornadoes form in the United States and then where tornadoes form in the whole world. So tornadoes, you need unstable air. And it works well, for instance, if your moist and warm air is being lifted up by your, your dry and cold air. So there's a figure from your textbook, I think, in a minute. It's going to show you Tornado Alley. Or maybe not, but this hot link, I'm going to take us to the internet. Where in the heck is Tornado Alley? Well, there's the old Tornado Alley and the new Tornado Alley. Okay, so it looks something kind of like this. Oops. So the old Tornado Alley and the new Tornado Alley. It looks like the old Tornado Alley was smaller, wasn't it? Were we in the old Tornado Alley? No. Even though Iowa State calls themselves Cyclones. But we're in the new Tornado Alley. So I've heard it described basically those old mountain ranges, or the old mountain range and the kind of newer mountain range. They actually are great at kind of guiding that warm, moist air to meet that cold, drier air. And so that's kind of how that works. So the United States, in the middle of the United States, we have a good situation for tornadoes to form. So this is a look at where tornadoes form around the world. And this is what I think is interesting. It's almost like, God bless the United States and nobody else. It's like we have a lot of tornadoes. Because at the beginning of this unit, we looked at not tornadoes, but we kind of built up to tornadoes. We talked about just lightning and thunderstorms. And thunderstorms are all over the place, okay? Well, a lot of tornadoes. So this is picking on the state of Illinois, and each one of those little arrows is the path a tornado took. And this is emphasizing a few things, how long the path of a tornado is, and that can really vary. And the other thing it's emphasizing is you definitely see kind of a trajectory from the southwest to the northeast sort of thing. That's generally how they go. From 1916 to 1969. So I don't have a lot of videos of tornadoes, although we're going to watch a video of tornadoes here, I think, in a minute. But of course, if you're looking for drama, Iowa's got a few tornadic events that kind of give you that, or give us that.
It's on the ground.
So the one on the left is what the United States tornado season generally is, but you can kind of see here, there are some states like Texas kind of has a couple of peaks, They have an early peak in May. Of course, Texas is south. And then they have another peak in September. Someone was reminding me that, like in December, we've had some crazy weather even. So, I don't know. Let's see. So, of course, you've heard about kind of those strange winds associated with a tornado. It's almost like they do magic. Like, for instance, they can take something weak like a piece of straw and drive it through a piece of wood, which never, otherwise would not happen. Like, oh my gosh. They can relocate things quite a distance. I had to look up what a gravity wagon is, so maybe you guys already know, but it's just like a little piece of farm equipment picked up and relocated a mile down the road. Yeah. There you go. So the thing that's been relocated the farthest, I think it's in a, it's like a Guinness Book of World Records sort of thing, but a Czech was relocated 223 miles, picked up and taken with the twister. My goodness. So the strange things that tornadic winds do. Okay. Strange / bad. And the guy said, that tree was debarked, and that's kind of, after a twister's gone by through, you see these bare trees. Just, that's craziness. Craziness. Well, sometimes conditions are ripe, and this kind of makes sense for not just one tornado, but a series of tornadoes. We talked about sometimes conditions are ripe for not just one thunderstorm cell, but multiple thunderstorm cells in a squall line or in a mesoscale convective complex. So this actually kind of makes sense. So we call it an outbreak if at least you had 6 tornadoes with that weather system. So, for instance, in 1925, there were 700 people were killed by this one tornadic outbreak. Let's see if this will do it for me. If I click on that. So you can find anything on the internet. This actually talks about that outbreak way back then. Sometimes I'm like, how did you really know? But so here's the EF enhanced Fujita 5 and regular F5. F5 is a rare type of tornado in general. We see a lot more of the weaker ones than those. So this is kind of the tri-state outbreak. But if you're like me, the fact that so many people lost their lives back in 1925, honestly, part of it is warning. They don't have the warning that we do. So, then in 1974, there were 148 tornadoes. And 30 of those were severe, the 4 or 5s. In 1999, there's another outbreak, Oklahoma, Kansas, Texas, and Tennessee. This is that 1999 outbreak. And the different colors represent, it looks like the different colors represent different storms, and then they say how many tornadoes were associated with that storm. So you can kind of see it generally went, again, from the southwest to the northeast. Here, we have a slide coming up that says Norman, Oklahoma. Somewhere in there, Norman, Oklahoma, there it is, right there. Actually, right there, ironically, is where they give us our watches. We have tornado watches and tornado warnings. Our watches come from there. So I'm like, oh my goodness, it's like karma or something. I just think that's kind of ironic. So yeah, you're probably familiar with this whole, like a E5 or an F5 okay, but now it's enhanced Fujita scale. And it's a little bit different than the old scale. Let's see. So, based upon the old scale, though, this slide has some statistics. And I told you that the severe ones are pretty rare. Okay? So the severe ones, as indicated by a 4 or a 5, F, EF, however you want to do it, there's only 2% of those. But notice that by far most of the people who lose their lives are those few tornadoes. Reminds me of the movie Twister, right? Where, yeah, the good niece was trying to save her aunt from, give it more of a warning anyway. So there is a difference. After break, we're going to start in on hurricanes. And you use a different scale for tornadoes and hurricanes. So tornadoes are the enhanced Fujita scale. The other big difference about tornadoes is they don't last very long. And you're not going to go out and get these wind speeds. Notice that these two columns here are wind speeds. So you can't get that while it's happening. So I just think it's interesting that after the fact, you go out there and you observe some events that happened while your tornado was there. And then you kind of do a little bit of detective work to go back to see, to judge what that wind speed must have been. You're not going to stand out there with a little cup anemometer. Yeah. But with a hurricane, now that's different because that lasts days and days, and they can send, we'll talk about that, but they have like survey airplanes that fly into them, and they drop gizmos and things like that. So these two columns are, again, it breaks it into weak, strong, and very strong. It's the last one. And the two bars are, the red bar is how frequent they are, and then the orange bar is how many fatalities are associated with that type. And this is just kind of consistent with what we looked at before, that if you look at your 4s and 5s, there are not very many, but we have a lot of fatalities. So you're probably already familiar with the whole watch warning thing. I mentioned that the watches go out from Norman, Oklahoma. Okay, SPC stands for Storm Prediction Center, and they are associated with the National Oceanic and Atmospheric Administration. So of course watches go out first, and I'm going to kind of show you there's like these what they call synoptic discussions. Basically, there's a lot of chatter of what the atmosphere is doing. And I don't know, I've never joined in, but like I said, I think it's kind of back and forth. And then warnings means that it is imminent. Imminent? Yeah. Warnings mean that a tornado has been spotted. And to me, if the atmosphere is ripe to give you one tornado, then of course you're like, oh, well, like kind of the video said, I hope there's not another one coming down, right behind us. And that sort of thing. So tornado warning means that one has been spotted in your area. And then the warnings actually come, I don't know, for you guys it's Peoria, National Weather Service, or if it's Quad Cities. That's two. What's that?
I don't know. I'm not sure.
I've heard it described, you guys are a little bit in the middle. Kind of
Yeah.
between the two. So those convective outlooks, we'll kind of take a look at this one. This should be the current one. Okay. Oops. So MRGL stands for marginal. Okay. So that means, of course, if we are right here, okay, we're kind of in the other side of marginal. But there's all sorts of different ways to look at this. So, for instance, let's see. I'll go to convective outlook. So you've probably heard these before. It has day 1, day 2, day 3, and it kind of goes out like that, which can kind of be helpful. Let's go back to the notes. Okay, so those are convective outlooks. Now, these are just kind of still images of what a convective outlook might look like. Like we had marginal a minute ago. Notice these are, the first one's any severe weather. This one is tornadoes. Okay, so again, it's kind of the probability. I know I have Geek weather friends on Facebook that will take screenshots and say, "Did you see this?" Like, oh no. So high risk, low risk, that sort of thing. This one is for damaging winds, and this is the probability of hail. Not so surprising that each one of these kind of has a bullseye over Texas, Oklahoma sort of thing. So tornado safety. Get indoors, basement if you can. Have you probably heard this too, that if you're gonna have to go in your bathtub, maybe drag your mattress with you? It's not gonna be easier said than done. If you're in a mobile home, get out if you can. My mom lives in a double wide, but she lives near a bluff, like Highway 99 bluff, so I don't know, I think she's okay. If you're driving, get off the road, seek shelter. Those chasers did not do that. Get as low as ground as possible. So how do we capture these, or how do we know that a tornado is on the ground? Now, if you go to the weather spotter, like now Philip went to the training this year, they will try to employ your help, because actually the eyes are almost more reliable than some of this other fancy stuff. But Doppler radar, I think I have a next slide what Doppler is. But Doppler radar basically gives you motion towards and motion away, in addition to whether it's raining. So I don't know if you're familiar with the Doppler effect that the Doppler radar uses, but basically if something's coming towards you, then, and if it's emitting a sound or an energy, then actually the pitch or the wavelength is going to get shorter, the pitch is going to get higher. So it's kind of like if you have an ambulance coming towards you, it'll go nee, kind of ramp up nee, as it goes past you. Then as something goes away from you, actually, the opposite occurs. So I think this might be a figure from your textbook. So notice the little squiggle coming from the ambulance. And so the emitter part is the ambulance, and the observer part is that person. So it has a certain wavelength of the energy or the sound that's coming. And as the ambulance is moving away on the second one, then actually you see where it's lengthened. So the longer the wavelength will have actually audibly a lower pitch, or if it's a visible thing, it will be kind of towards the redder end of colors. So this kind of does the same thing down here, where actually this one you have two observers. You have an observer here, a stationary observer here, and your point is going to move this way. It's going to start here, 1, 2, 3, 4. And notice that as it moves towards X, actually X is going to see it shorter wavelength, squished together, and as it moves away from Y is going to see a longer wavelength. But anyway, that's how Doppler radar works. And a lot of times if there is some sort of interesting weather event going on, they'll talk about Doppler radar looking for tornadoes. So let's see how that works. Doppler radar looking for tornadoes. So I kind of have a pair of images here. I have regular radar, which is this one. And this is kind of what we're used to looking at. The regular radar, the green is just normal rain, and yellow is pretty hard rain, and red is very hard rain. So you can actually kind of see a core of red intense there. So this one over here on the right is the same weather event, but now the radar is Doppler radar. So if you are looking for some sort of cyclonic movement, the mesocyclone, or heaven forbid a twister on the ground, basically you want to look at something coming towards you and something going away from you, towards you, away from you. So you're looking for what we call kind of just a tornado vortex signature. You're looking for red, green, kind of in a short amount of time. And so they've kind of over here in the Doppler radar shown you where that is. Right, it says tornado. And it's right kind of right here. That's the pair. Toward away, toward away. That's your rotation. So this is regular radar, and this is Doppler radar. Now, with regular radar, I don't know if you can kind of see this. It's called a hook, kind of like there's a little hook, like your finger would hook like that. And in your hook, that's where you're going to have your hail and your tornado in that vicinity. And it is. So a tornado vortex signature, a TVS. And when the meteorologists come on, because there's warnings or watches out, they'll kind of talk about those things. The other thing I said a minute ago was the hook, the little hook we saw in the normal radar. That's called a hook echo because all radar basically is an echo. The regular radar basically is sending out an energy beam, and if it doesn't come back, it didn't hit anything. Okay, if it comes back, that means it hit rain, and the more that comes back, the more intense the rain that it hit. So that's kind of how that goes. So sometimes, I don't know, you have to look at these a while to kind of see. There's a hook on the left, that's your regular radar, and then on the right, you see that tornado vortex signature. And another pair. I've heard them say that, what do they call it? Artifacts, maybe. Like this right here, this strange looking stuff right here. Okay, that is just because of the city, I think, kind of giving that sort of glow. But I definitely can kind of see a hook here. So you expect to kind of look to see if there's rotation there. Oh, more Oklahoma. Some places definitely got hit more than others, multiple times. So this actually, cute little thing, is a Doppler radar on wheels. I think I've seen those before. And, it's not an entire surprise when the weather turns severe, because if you've been kind of watching the water content and the temperature of your air masses, conditions are ripe. And in fact, they've even in those discussion panels, they'll talk about that. So they can have time to get a Doppler radar there. And this is a pretty good example of it's hard to tell because it's not moving, but that looks like a pretty good thing dropping down from the base of that's your wall cloud. Okay, so this is a stationary Doppler radar. And these are your happy people behind the scenes. This map of the United States is showing you, excuse me, locations for Doppler radars. One of the things I think is neat is that on the internet, when you pull up a weather map and it basically shows the whole United States, what the surface conditions are, they are working together to basically compile all that information. I just think that's neat. I like it when they can play with each other like that. Okay, so the thing I want to show you, I think, is about 20 minutes, so I think that will be fine. Then we'll take a break.